Okay. Then start with, so number one, what are the null and alternative hypotheses for ANOVA? The hypothesis is that the null hypothesis is that all the means are equal, and the alternative hypothesis is that one or more of the means differs from the others.
Okay, for one of the assumptions for ANOVA, what is the rule for examining the variance of each of the samples? If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Yeah. Differences between the tests of hypothesis for ANOVA and the other tests of hypothesis that we have covered to this point of the class, and I put that we now have more than 2 means we are working with, so 2 or more means. Well,
awesome.
More than. So.
Yeah. Okay, ANOVA, according to William Butler Yeats, she is a Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and nonfiction writers. The ages at death for female writers in these categories from North America are given in the women poet data. You would like to determine if the mean age at death is different from any of the categories of writers. Use sigma equals 0.05 as the level of significance. Design the study. What is the research question? Is the age mean of death different from the category, different between the categories of writers?
Okay, and then state the null alternative hypothesis, which is null is all the means are equal, and alternative is one or more of the means one or more of the means differs from the others. Can't say that.
I collect the data. Describe the data collection procedures. I just wrote each culture and each female from each culture were examined on their age of death. They didn't really have too much of a data collection procedure.
Yeah. So in a short paragraph, summarize the data. After the paragraph, insert an appropriate well-labeled graph to cite the data. I didn't write a paragraph. I just put the sample for each novelist, poets, and nonfiction, the mean and the standard deviation for each one. So novelist was N was 67, mean was 71.45, standard deviation was 13.052. For poets, sample size is 32, the mean is 63.19, and the standard deviation is 17.297. And for nonfiction, sample size is 24, mean is 76.88, and the standard deviation is 14.097.
So for this part, go ahead.
No, go ahead.
How did you, for the summary statistics, you used did you use SPSS then for that?
Right.
And then did you just do analyze, compare means, one way ANOVA, or how did you get those?
Yes.
Because I tried doing that and I just am not getting.
Okay, let me pull it up here. I was just opening everything up, so let me do that real fast. Okay, if I can click on the right button. And I did not want Siri. Sorry, I got too many things going here. Good. All right.
Sorry, I can't help you with that here.
Back to Siri. All right, what's going on? Oh, yeah, let's put that up that way. Is that a lot of stuff in there? You shouldn't play with. Yeah, you don't want to play in there. He says, yes, I do. We have our grandson here today, so.
Oh, fun.
Okay, so I did analyze, compare means, and one-way ANOVA. So you highlight A to put it in the dependent list, and then type and put it in the factor,
Right.
and click on options
Mm-hmm.
and highlight descriptive.
Mm-hmm.
I think I did a homogeneity of variance test and means plot. I don't know if
Okay.
we need all those, but I did those three and click continue and then okay.
What about for missing values? Do you click on either of those? Because it's already on exclude cases, analysis by analysis.
Hello.
Hi.
How's it going? Sorry I'm a little late.
Hi, Bryce.
No worries. We're on the preparation assignment question,
Okay.
part 2, question 1, number 3. I'll just press continue.
Exclude cases analysis by analysis was already, it was default marked, yeah.
So I got this weird, on the mean plot graph, I got this V, like graph.
Yeah.
That's what it is? Okay.
Yep.
So what did you say your, I just want to see if I got the same numbers because
Okay,
for
so
some reason
for
my
that, okay, yeah, so for the, under descriptives, so then you have for number 1, which is novelists, you have the mean sample size of 67, the mean
Okay.
1.45, standard 13.0. Okay,
Mm-hmm.
looks like you got that.
Perfect.
Yep.
Yeah. Great. Number 4, make inferences. What type of hypothesis test is appropriate? And I said the ANOVA test.
What are the requirements for this test? The data are normally distributed and the variances are equal for each group, which is then the whole has to be less than or equal to 4 times.
Great.
Whatever that is.
Bryce, were you able to do the preparation assignment? Bryce, were you able to do the preparation assignment?
Yeah, a little bit. I really glanced over that just kind of briefly.
Okay.
And then I just jumped
Okay.
into this thing. So
Okay. For C, are there requirements to make the test explains will require plots and simple calculations? So Evelina, did you do the same? Was it the same thing you did? You just use the same descriptives for this
So
answer and the plot?
So the variances is the standard deviation squared. So you take the largest standard deviation and square it. So the 17.297 and square it, which is 299.186.
Okay.
And smallest one, which is the 13.052 and square it, which is 170.355.
Okay.
So then 99.186 is not 4 times larger or
Right.
equal to 170. So we can conclude that the variances are equal.
Okay.
So we pass that one. Because our sample size is, we have a sample size that's not large enough, we do Q plots.
Okay.
And so then this is where and I don't know, Bryce, do you know a different way how to separate out the data to do a Q plot for each individual? All I know how to do is
I
highlight.
don't.
All I know how to do is to highlight. So I highlight
Yeah.
age and 1 and then highlight all the way down that section.
Uh-huh. Yeah, that's pretty much what I do too.
So,
I'm not sure of a better way.
All of the age section, is that you're saying?
let me show you. I'll show my screen here just a sec. Okay. So can you see this? I highlight
Mm-hmm.
these 2 rows, age and 1, and highlight all the way down.
Okay.
And then I go up to Analyze Descriptive Statistics, QQ Plots.
Uh-huh.
The variables, and then OK. And then it gives me the Q plots for the novel.
Oh, awesome. Okay, got it.
And then go back and look for 2s. Highlight down. And then,
Okay.
and then same thing. Analyze descriptive Q plots. Age. I reset it and put it back in. I don't know if you have to.
Okay.
And then it gets you now for number 2.
Awesome. Okay, great. Perfect. So,
I'm assuming that worked. I'm assuming that's what it's showing me.
yeah, well, it looks, in the answer key, those graphs look the same as what, yeah. Okay, so then, compute the test statistic. Would that still be on the same part of SPSS? Does it say that there?
I have to find where it's on. I figure out where am I have so many windows open right now.
Mhm.
So F is so there's one titled ANOVA,
Uh-huh.
and then F is your test statistic.
Oh, okay. 0.563.
6.5, yep, 6.3.
And the state degrees of freedom.
So it's on the same one, your DF, just 2.
Okay.
And then the p-value is that sig, the SIG sig. I don't know what that stands for.
Okay. Yeah.
0.02.
On the it says compared to the alpha level, so just is less than.
Less than 0.05.
Awesome. Okay, make a decision. Do you reject the null hypothesis or fail to reject it?
So it's less than, so we reject the null hypothesis.
Awesome. Okay.
So present your conclusions in the form of an English statement. There is enough evidence to suggest that one of the mean ages of writers is different than the other mean ages of writers.
So, with further study, we find the poets die earlier than the novelist and nonfiction writers. What significance can you conclude from this? All that I said is that the mean was affected most by the poet who differs from the others, or from poets that differ from the others.
Yeah. I said if I were a poet, I'd be worried.
Yeah. Okay, awesome. So we can do the group quiz now. Okay.
Okay, and in an ANOVA hypothesis test, we reject the null hypothesis when there's sufficient evidence to indicate at least one mean is different from the others.
True, right?
Yeah. Yeah, I've got true for that one.
Okay.
What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. So data in each group are normally distributed is one of them, right?
Yeah. And variances are equal in each group.
Yeah.
Jordan?
Check if each group is normally distributed. Do the following. Construct a QQ plot for each group.
Awesome.
We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller, the largest variance, the largest is less than 4 times the largest sample mean is less than. The largest variance is less than 4 times the smallest variance.
Okay. An ANOVA hypothesis is equivalent to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2. How many pairs are there when there are 4 samples?
How do we figure that out?
I don't know how to figure that out.
There's 6. We'd have 1,
1, 2, I think it is 6.
2, 3, 4. You'd have 1 and 2,
No, maybe.
1
No,
and 3, 1 and 4, 2 and 3, and
I
2
think
and 4.
No, 1 through 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4.
7.
So you, I think it's 6. What do you guys think?
Yeah, I have down 6. Yeah.
Okay.
Okay. Bryce, you're ready for the next one?
Yeah. So the data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each now represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What is the minimum smallest variance for the 6 groups? For that, I found in group C with a variance of 27.208.
Did you do that on SPSS?
Yeah. Yeah, so I just calculated the variance for each of the groups, and that ended up coming up as the smallest.
Okay. Okay. You said you had 27.208.
Yeah.
Okay. And when you did that, so you selected all of each of them, so A, B, C, D, E, right, individually.
Yeah. Yeah.
And
So
then
I
did
did
you
the individual variance, and then just did the like if you just do the
You have to transform first. You have to transform.
Yeah. Yeah. So I separated the groups and then did them each individually, just to analyze.
Okay.
And, what's it called? Yeah, descriptive statistics, explore. Right. Pop up all the.
You got 27.208, you said?
Awesome.
Because I
Great.
5. Wait. So the smallest standard deviation I have is 5.216.
But the variance,
Yeah, he wants the variance.
Right, so I squared it.
right above that. Well, if you see on the on SPSS right above, it says the standard deviation. It says the variance is 27.208.
Where are you looking at?
On under descriptives on SPSS,
Uh-huh.
if you go down to C, it'll say so either like mean, 95% confidence interval, 5% median, variance, and on the variance it says 27.208.
Mine doesn't
You see that?
Mine doesn't say it.
Did you just select C? Because mine actually did it for all of them. I just selected C, but it did it for all of them, and I got that same answer.
So tell me one more time, what did you do? You're looking at descriptives.
Yeah, sorry.
Yeah, and It's okay. I can tell it. Under descriptive, you have it say like kicking accuracy on the left, right?
Yeah,
A, right?
right,
Then if you go down, there's B and there's C.
right.
And under C, there's the mean says 29.45. Is that what yours says? Is that
Yeah.
what yours says? Then it says 95% confidence interval. You go down to variance. And it says 27.20.
Mine
Yours
doesn't,
doesn't say that?
mine doesn't have a variance.
Weird. Did you do analyze? What was it that you said to do? Oh yeah, descriptive statistics. Wait, what? I don't even know what I even just did
I
to get
did.
this now.
So analyze and then descriptive statistics and explore.
Okay, yeah. Is that what you did, Evelina?
No.
Okay.
There we go. Nice.
You get it?
Yep.
So then, is it your turn to read, Evelina?
So what
I
is
think
the
it is.
maximum largest variance for the 6 groups?
I think it's 53.158. Is that what you wrote, Bryce?
Yes. Yeah, that's what I got as well.
So for D,
53.158.
okay. The test for equal variances is satisfied for these data. I don't, it's not, right?
I believe it is.
It is.
Actually. Yeah.
I thought it had to be 4 times. What's the number that has to be 4 times?
It has to be less than 4 times.
Oh, less than 4 times. Sheesh.
Mhm.
Okay. Got it.
All right. 11. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots, true or false. And I have down true.
Okay. So from there, I just did, let's see. Can you do it from that page, or do you have to select everything and do it?
Yeah,
You know what I mean?
yeah, same thing, just select each
Yeah.
one and do a QQ plot.
Okay.
And they are looking normal, so. Well, hello, Hanson. Hello.
Okay.
So yeah. So that would be
True.
true.
Okay.
Hey, Jimmy.
Whose turn is it to read?
So perform an ANOVA. Oh wait, was it yours, Bryce?
I just did that last one.
Okay, perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when you remove the SOX data?
Hey, buddy. Where you going?
No. Why am I only getting one? I'm just getting one thing to put into the dependent list, just kicking accuracy. I don't get, and it's not letting me press it.
Push reset. And then see if they both come.
Only one thing that's letting me put it in there. Hmm.
Did you
I got point.
do what's it called again? The automatic recode.
No, how do I do that?
You know?
A recode into same variables?
Yeah, so if you go up to transform, and you go down to automatic recode, should be like right in the middle.
Okay.
Click on that, and then you should be able to take your category. So, sorry, I don't have it open on right now. On
But
this
wait,
one.
all of them?
But where? So
You put over the categories, so it says we're
Footwear.
talking about shoes, right? Or what are we talking about?
footwear.
Yeah.
Yeah.
So
Okay,
if you
footwear.
put footwear over into the variable type, and then you'll put in a new name, and then check the box that says use the same recoding scheme for all variables, and then just hit OK, and then it should give you a new column that has numbers in it rather than names, and you can then use that as your factor.
Yep, got it. So let me just see if I can get this now. Perfect, yeah. Awesome. And what did you say that you've got for this one?
So I got 0.309 after doing without the SOX data in there.
0.309 was that what you said?
Yeah.
Yeah, that's what I got.
Where does it say that? I must have done something.
Right under the it says SIG, the SIG, the same as the p-value.
You did it twice.
One. Is that what you guys just said, or did you guys say something else?
Did you go up to analyze and do one sample mean?
Yeah.
Means and one way Nova?
Yeah. So what did you end up getting?
Yeah, I did. 0.471. Oh wait, 0.081?
Okay, yeah, that's with
Wait a
the
minute.
SOX data in it then.
What'd you say?
That's with the SOX data in it.
Uh-huh.
We're supposed to take the SOX data out and then do it again and see what
Oh,
the different p-value is.
okay.
Sorry.
What'd you guys say you got?
We got 0.309.
Okay, awesome. Great. Okay, the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
It's to the right.
Yes.
Okay. Okay.
Okay. I don't know who's up. I'll read. Research at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the hot dog nutrition file. Use this data file to answer the remaining questions. let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
Um, think that they have been met, but I don't know. Do we have to do each of them, right? Each types.
Yeah.
That is.
What do you guys think?
I have down that yes, the assumptions have been met in the first one.
Okay, that's what I think too.
Yeah.
What about you, Evelina?
Yeah, it takes my system a little bit longer to get going, but I would say yes too.
Okay. Okay, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P equals 0.000 with a level of significance equal to 0.05. What conclusions can you draw?
Yeah. You want to change? Would like to change? Or about my house? Okay, I can change. Yeah.
I don't know. I don't know what you would put for this. 'Cause it gives you all the information right here, but
So if it's less than 0.05, we have sufficient evidence to claim that at least one of the hot dogs types has a different mean number of calories than the other type, right?
Yeah. That's what I have as well.
mhm. Okay. You said we have sufficient evidence to claim that at least one of the hot dog types has a different mean number. Is that what you're saying, Evelina?
Yeah, that there's at least one
Yeah. Okay.
that types has a different meaning.
That's fine. Bryce, do you want to read number 16?
Yes, I do. Now let's examine the sodium levels. Construct QQ plots for the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot poultry suggests a possible problem with the normality assumption. The smallest variance is 7,180.75, and the largest is 10,492.871. Have the assumptions been met to use ANOVA? And I put yes that they have done that.
Great. Cool. Okay. Is that what you think too, Evelina? 16?
Oops, can't. Yeah, I was just gonna do something here real fast. Sorry. Yes, I would agree. Despite the possible problem you caught for poetry, you decided to use ANOVA to determine if the mean setting modes are the same for all three. What is the p-value for this test? Come on. Alright, so the p-value is 0.179.
Mm-hmm. Yeah, I think that as well.
So we can conclude.
What conclusions can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level of significance of 0.05. We have. What do you guys think? Do you think we have sufficient evidence?
So it's greater than 0.05.
Yeah.
We do not have sufficient evidence.
Okay.
Reject claim, right?
Yeah.
Mhm.
So you don't have sufficient evidence to reject the claim.
Okay, did we get them all?
Yep. Awesome. You got 100%.
Well, that's always nice.
Awesome. Okay, so we'll meet again on Thursday then.
Yes.
Yes, so we can get ready for the exam.
Yeah.
2 classes with exams this week. I'm like,
Gosh, dude.
why is that? So,
Yeah.
anyway,
All right.
guys.
Okay, see you guys then. Bye.
Okay.
On Thursday.
All right, thanks. Bye.